So here's our next question now. We are doing part B, which is another walk in the park. These are definitely, all these questions are definitely a walk in the park. It says determine the vertical asymptote, horizontal asymptote, and whole, if any. So we know that we have, for asymptotes, we have these three, yeah? We have actually four things, four words that are mentioned in the topic of asymptotes. Horizontal asymptote, vertical asymptote, slant asymptote, and a whole. Okay, these are all mentioned in that topic where we have problems. So now we know that horizontal asymptote and oblique or slant asymptote, those two are called the end behavior of a function. Then we have the vertical asymptote and the whole. They're called domain issues. They are called domain issues. So now what we do is, whenever we are looking for, we know that horizontal asymptote is the only of all these things that has conditions. Horizontal asymptote has conditions. So when we want to find it, we have to use the conditions. If you have forgotten, you can go watch the summary video which I did to remind you that horizontal asymptote is the only one with conditions. The others we work out. You just need to know what we change. So here, determine the vertical asymptote. So I can start with the, they said vertical asymptote and horizontal asymptote, whatever. So for vertical asymptote, we put our f of x being equal to x squared minus x minus 6 all over x squared plus x minus 2. All right, so the first asymptote, which is easier to find for something that has not been factorized yet, is the horizontal asymptote. Okay, what do? You just compare the highest power of x in the top to the highest power of x in the bottom. What is the highest power of x here? Is 2. In the bottom is 2. They are the same. So they have the same, the highest power is the same. What do you do when the highest power is the same? You need to know the three conditions. When the highest power is the same, you divide the number in front here with the number in front of the denominator. So you can say horizontal asymptote, horizontal, can put that horizontal asymptote. Remember that horizontal, it's called the horizontal asymptote because it is a horizontal line. And horizontal lines are the lines y equal to something. They are always y equal to something. So horizontal asymptote is y equal to something. It's a line. Okay, so it'll be y. So horizontal asymptote is, what do you have? You have y equal to 1 over 1. You take the number in front here. It's 1 divided by that at bottom. That's the 1. So y is equal to 1 over 1, which means y is equal to 1. Okay, so you can write it, I mean, nicely to say the line y equal to 1 is the horizontal asymptote. Okay, is the horizontal asymptote. Now we go to the vertical asymptote. For vertical asymptote, what do we put? We put again f of x is equal to x squared minus x minus 6 all over x squared plus x minus 2. Now we already did the factorization of the top. We got x plus 2, x minus 3. So I can say this is going to be equal to x plus 2 multiplying x minus 3. And it is all over. Here we have x squared plus x minus 2. We want to factorize again the denominator. We take this last number as it is. It's a minus 2. Put it as over t because there's just an x squared here. So what are the factors of 2? We don't say the minus 2. Factors of 2, it's 1 and 2. Now, once we see it being a minus 2, it means that the 1 and 2 should have different signs. You come to, how do you know which sign to put on who? You come to the middle thing. The middle thing is positive this time, which means the bigger number is positive, which means the smaller one is the negative one. 2 minus 1, will they add to give me the number which is there here? The number which is there here is a positive 1. 2 minus 1 will give me a positive 1. Yes, so these are your factors, x minus 1 and x plus 2. Remember, you did with a pencil, x minus 1, x plus 2. Here are the factors. Then what do? You can see that, oh, I have here this and this cancelling, right? So you can say, and you'll be having it being equal to x minus 3 all over x minus 1. You can say for whole, you say you choose the factor that canceled out each other, this one, x plus 2. So you can say let x plus 2 equal to 0, and you will get it now saying x. Okay, you can write below, say let x plus 2 equal to 0, which means that x will be equal to negative 2. You can say, therefore, no, now you have found your x being negative 2. You can now say f of x is equal to, we'll take the simplest version here, which is x minus 3 over x minus 1. A whole is a point. We need the coordinates. So here we know it's at x equal to negative 2 because we let the guy which has cancelled, the common factor, that is what you make it be equal to 0. You let that one be 0. then they cancel, whatever. Now we solve. Then now we are going to take this x value and put it to see what is the y value of our whole. F of negative 2 is equal to negative 2 minus 3 over negative 2 minus 1, which becomes negative 5 over negative 3, right? Which the negatives cancel, it becomes positive 5 over 3. Right? So now we have it like this. So we can say, therefore, there is a hole at, we now put the coordinates. What is the x? X is negative 2. What is the y? 5 over 3. So it's negative 2 comma 5 over 3. This is where the hole is, and you would be done. This is for the hole. Now you can say, we keep going. I mean, this is just so easy. So we can now say, for vertical asymptote, we are going for it, okay? For vertical asymptote, now you skip some lines, to make it neat. You communicate. You're now telling them you're doing the workings for the vertical asymptote. You can say, you go back, you can report to say f of x is equal to, you put the version that has gone through the factorization and cancelling, okay? X minus 3 over x minus 1. So it's x minus 3 over x minus 1. You can now say let x minus 1 equal to 0. And if you go to the other side, you get x equal to positive 1. And remember, asymptotes are lines, so it would be done. You can already say the line x equal to 1 is the vertical asymptote. Remember, vertical lines, vertical asymptote is a vertical line. That's why it's called the vertical asymptote. And because it is a vertical line, that means that it will always have x be equal to something. These are what the vertical lines are. It's x equal to something. So here it is. We now have the vertical asymptote. We have the hole. We have the horizontal asymptote. And we are done. Now we are going to part C, which is to sketch the graph. Goodbye for now. See you in the next one. You see how easy it is? These are 5 marks just for doing this. We have to get them. Okay, we want these 5 marks. All right.